Welcome to today's video. Today we're going to be focusing on writing the symbolic form of conditional statements, and we're also going to begin focusing on truth tables. We're going to show that mastery in class by scoring at least a 70% on an exit ticket. Hopefully you have the notes in front of you. If you don't, take out a fresh sheet of paper and we'll get you a blank set of notes tomorrow. Now, we've already talked about conditional statements, but we want to talk about different ways we can write it. So, if we start with our conditional statement, if you remember from the previous lessons, it always starts with an if. Has to. Then we have our hypothesis. When we talk about a hypothesis, this is going to be P. So if P, well, then after our hypothesis is our conclusion, and it's going to be Q. So if P, then Q is the same thing as saying if our hypothesis, then our conclusion. Another way we can write this, and you'll see it written, is P arrow Q. And this just means P implies Q. When P implies Q, we write it as a if-then statement, a conditional statement, saying if P, then Q. Now, if we want the opposite of P, so instead of saying I did my homework, I wanted to say if I don't do my homework, we're going to put, it's called a tilde or a little squiggly. So negative P means not P or the opposite of it. So if it says I did my homework, the opposite would be I did not do my homework. Now, we're going to talk about how to write the different types of conditional statements. We've talked about these, but when we talk about a converse, this is just one way we switch it. So our original is P arrow Q. Well, if I switch it, I'm going to do Q arrow P. So our converse takes our conclusion and switches it with the hypothesis. And we're just worried about what the symbolic form is. I know you already know that, but we need to know what the symbols look like. As far as our contrapositive, in this case, we need to switch it and negate it. So again, if we start with PQ, well, if I switch them and negative, it's going to become not Q implies not P. And again, I know you know how to do this, but we need to know how to write it in symbolic form. If we talk about the inverse, we are just negating it. So if I start with P implies Q, now it's going to become not P implies not Q. We've talked a little bit about the biconditional. We want to make sure we're still talking about it. It's not as prevalent, but just in case. What you're doing is you're combining with the converse. And if I have P implies Q, if we think back to biconditional, it was when P is if and only if Q. So we're literally going to write it P if and only if, so IFF Q. And that's your biconditional statement. P is always your hypothesis, Q is always your conclusion. Now, when it comes to truth tables, there's two different types we have. First, I want you to take this, and unfortunately the math symbols aren't the best sometimes, and we want to draw it down so it's not just a little arrow. Now, this arrow from the first one, we are going to call this our conjunction. And what that means is the word and. If we have the word and I'm giving two statements, that means it is true only if both are true. And we're going to talk about that. But it can only be true if both parts are true. So if I say Miss Yapel is my math teacher and Miss Yapel is my science teacher, Well, that can't be true because I'm not your science teacher. I'm only your math teacher. So that would be considered a false value. One way to remember that it's and, this looks like the start of an A. Well, A stands for and. Our second one is what we're going to call our disjunction. And this means or. In this case, it is true if one is true. So Miss Yapel is my math teacher or Miss Yapel is my science teacher. Well, that's true because I am your math teacher. It doesn't matter that the science teacher is false. Now, we're going to talk about what the beginning of truth tables look like. When we talk about negation, remember, it's when we put that little negative sign there. If my original hypothesis is P, it's going to become negative P. You can have two values for your hypothesis. It can either be true or it can be false. Well, the opposite of true, because a negation is just the opposite, is false. The opposite of false is true. Now, when we do a conjunction, and I'm going to start with the basic one. If I say P and Q, your truth table, you always need every variable to start as your labels. So I need P and I need Q. Your last column should always be your problem. So P and Q. Now, here's where it's different when you have two variables. Instead of only having two columns, we need four because, again, we need all the options. I can either have P is true and Q is true, or P is true and Q is false. I can have P is false and Q is false, or P is false and Q is true. Now, if we look, a conjunction is and, so I need both to be true. Well, if I look, I have two trues, so that must be true. I have a true and a false, so that's now false. I have a false and a true, so that's false. And two falses are false. So in this case, the only one that is true is that very first one. When we talk about a disjunction, this is our or statement. So, again, we're going to start with our variables, P and Q, and then our last column is our problem, so P or Q. Again, we need to list all of our options. So now, when we talk, this is our or, and this one we only need one truth value to be true. So we have two truths. Well, that's at least one, so that's true. If I have a true and a false, I have at least one, so that's true. A false and a true makes it true. Two falses, though, there's no truths, so that has to be false. The biggest difference between a conjunction and a disjunction, a conjunction has to have two truths, a disjunction only has to have one. Now, our last example. This one's a little bigger, but just like order of operations, we're going to start with what's in parentheses. Again, I want to start with my variables, so I have P and R. My third column is going to be for my problem that's in parentheses, like my order of operations. And my last part is going to be for my actual problem. Now, keep in mind, this is for or, so we need one. And this means the opposite. So, we're going to start by listing all of our possible values. True, true, false, false, true, false, true, false. Now, or means I need at least one. Well, if I look, these two is true, those two is true, those two is true, and that is false. Now, I don't need these anymore, so I'm going to cross them out, just so I don't accidentally look at the wrong column. Save yourself from making a careless mistake. Now, the last column, this symbol means it's the opposite. So I'm going to take the opposite of what I already did in parentheses, which is this column. So the opposite of true is false. The opposite of true is false, false, and true. So your final truth table, the final answer column, is your last column once you've performed all the operations on the truth table. I know it's a lot and it's a little weird because it's a lot of trues and falses without any statements. We're going to continue to work on this in class tomorrow. Please bring your notes, and I look forward to seeing you then.